This limit problem is a tricky one, and maybe many of you have gotten this wrong like I did back in college, but I'm here to help you out because you're told that we need to figure out the limit as x approaches 3 for f of x, and f of x here is a piecewise function, and here's the problem. We're told that when x equals 3, the output value is a 5, right? But here's an issue. We're also seeing that for x squared minus 2x plus 1, if you were to plug in a 3, you would not get a 5, you would get a 4. And then that's the same for 2x minus 2, you would also get a 4. So what is the answer to this problem? And are we just being tricked? Well, stick around because I'm going to reveal how to make sure you don't get this wrong on your next exam. Before I dive right into how to solve this limit problem, let me introduce myself. If I haven't met you, my name is Dave, and I used to tutor calculus students like you back in college, and I'm actually a software engineer, and I've even made a really fun ninja math game you can check out in the description below if you want to be quicker at mental math before your next exam. So the first way I want to solve this limit problem is I want to start by just graphing everything because it's just easier to visualize things sometimes. So graphically, if I were to tell you what is the limit here as x approaches 3, it may not be super clear just yet. This 0.35 might be giving us some problems because we can tell that the parabola and the line are not going to have a value of 5 as the output if you were to plug in a 3. And it looks like we have some weird jump discontinuity, doesn't it? Well, what is the definition of a limit anyhow? Well, remember that it has nothing to do with whether or not the function f of x is defined at x equals 3. And another thing too I want to mention is this 0.35 might actually be a distraction in disguise, and you're going to see how. So remember though, for a limit to exist, what does it tell us? Well, for a limit to exist, it would mean that for approaching 3, I would have to approach it from the left, like I'm showing here. It would have to give me a value, and then I would need to approach the function from the right. And if I get the exact same value for both, that's actually a number, then we know the limit exists and it actually is that number. Okay, well, what does that mean here? What happens when I'm approaching f of x from the left of 3 and I'm walking towards 3? Think about the domain and for a second, pretend you don't see what the value of f of x is at 3. Just look at this area here and only that part of the domain. It's very clear that the only thing that has to do with the domain when x is less than 3 is this parabola. Now imagine you're a little ant and you are walking towards the value of x equals 3 up this hill. Pretend you get really close. You tell me in the comments below and think about it. Is the limit going to be 5 or is it going to be 4? If you got the answer as 4, congratulations, that is the correct answer, because I want you to think about getting extremely close to this value right here, this open hole. Think about values where x is 2.999999, etc. You actually approach an output value of 4 because that value at 3.5 is not on the domain here. It's a trick. Okay, so we know then that approaching f of x from the left of 3 is going to give us basically the result of x squared minus 2x plus 1 walking towards 3 from the left. And we saw that's a 4, right? So now what we want to do is say, okay, well, we know what we get when we approach 3 from the left. What do we get now when we approach it from the right? Well, let's go back up to the graph and see. Similar idea, but on the opposite side of 3 now, right? When you look at the graph now, again, I want you to pretend you have a blinder and you don't see this point here. Start from the right. Now walk down this line, pretending you're a little ant, and get really close to x equals 3. What are you approaching? Are you getting a value of 4 or a 5? And tell me below. You tell me what you think. Okay, just like before, I hope you see that the answer here is that you approach 4, not 5. So now we see that for f of x, the behavior is the same whether you approach 3 from the left or the right. But hang on, does that mean the answer is a 4? Well, here's the deal. Remember that the traditional value of a limit at a point or x equals 3 has nothing to do with whether this 3, 5 point here exists. We are only looking at behaviors. And so what makes this problem a tricky problem is this point was a distraction all along because it wasn't actually defined as part of the limit intervals because you're walking really close to x equals 3 without actually ever getting there. So believe it or not, the answer is a 4. And if you want more limit exercises you want to tackle before your next exam, check out this other one because it's a fun one.